This is your host, Andy Dumont, and I am excited to bring you guys this month's episode on the infrastructure people. So I know everybody is starting to feel the effects of the social distancing and being crammed at home. And I wanted to give you a little bit of an idea about what it is that these people that are doing this essential infrastructure work are doing and how it's set up, who these people are, and how it affects you. In my last blog post from March, I had talked a little bit about how diversity and inclusivity really helps you as the end user. And this week I want to talk a little bit more about, okay, well, how do we talk about it in the industry? What are the sorts of procurement rules we have, and how could we do it better? So let's get started. As we're all at home baking our homemade sourdough starters and trying to do our part to flatten the curve of coronavirus, there are people that are putting on their gloves and heading into work, and they've added a lot of extra hand washing, sanitizing down all the surfaces, and logging the temperatures every single day. There's a sheet posted on the construction trailer wall somewhere that has my temperatures charted, and some days I was doing my mouth, and some days like, okay, where is a different part of my body? One of my employees uses her armpit every day, and so my temperatures are a little bit haphazard because there's just so many different places that I did my temperature on. And then we realized, talking to our health and safety guy, that that's actually a HIPAA violation to have your personal information posted to the wall, which we didn't know, the clients didn't know. So we've since changed it to a pass-fail. So if you have a temperature of 100 degrees Fahrenheit, or more, you fail, and then it triggers all sorts of other processes to get you home and get you tested and sanitize anything you might have touched. So we're all learning throughout the process, and that's a little bit about how it's been going. Yeah, so a little bit of extra work, but we had one case on site, and nobody else got it after that, and so we think we've been doing a pretty good job. And I think it's going to change how we work as the industry. So right now, the infrastructure work is not emergency work. It's not like healthcare workers that are on the front line that are putting in their full suits of PPE. It's more of, how do we keep our ovens going? How do we keep it so that when you turn on the faucet to bake your sourdough breads, water comes out, how this your toilet water goes out into the system, and then you don't even have to think about it. That's essential infrastructure. There's also other types of essential infrastructure. Obviously, I do water, so I know a lot more about water and wastewater. But there's also the people that are building the facilities that will one day produce the vaccine. We don't know what the vaccine is going to be yet, so I hear. But we want to start building the facilities now so that when we do know, they're ready to go. The people that are the essential infrastructure people, they're people like me who are engineers, they're operators as well. We're very diverse, lots of different demographics, social values, political structures, ethnic boundaries, very diverse personalities. So essentially, we're just like you. We are a subset of you, and we are hopefully helping to build the world to be better for you guys and ourselves. And so it's important, because we work for you, that we are transparent with what we're doing and how things work. We need to be transparent about what the status quo is right now might have helped back in the time that it was built to be progressive and get to where we are now, but it's doing a disservice by clouding what we could be doing to be better. And to do that, I think we need to back up to what is the current structure of inclusivity and diversity. What does it look like today, and how do we change it so that it will have a better quality designs, more profitable companies for their shareholders and all the people involved, and is ultimately something that produces a better built world. So how it works. Each project, plant, or public work starts with an idea. It's in the water market, it could be the operator saying, I think you need to add another pressure tank over here, because in the morning when everybody takes their showers at 7 a.m., it's kind of it's a hilly zone, and the pressure goes down in that zone. So the operators intuitively get it. They know through trial and error in real time as it's happening what sort of changes affect the system. It's basically the independent variable experiment, but in real time. Sprinklers they tend to have a default setting of 5 a.m. to turn on sprinklers in everyone's yard. So fun fact, the water in the system probably has the biggest dip in some of the graphs I saw, which I think were specific to Bryan College Station. It dipped down at 5 a.m. when all the sprinklers turned on, just because people don't change the default settings. They think, oh, like that's when you should be watering your yard, and maybe it is. I have no idea. I can't hardly keep the plants on my balcony alive in the Texas sun. But so 5 a.m. is when we see the biggest drop of water. So we have to be prepared at 5 a.m. for that huge drop of water that happens basically on the dot every single day. So my favorite fun fact is that in the UK, when EastEnders turns to commercials, they had to roll on turbines from France because there was a 1.75 million tea kettles that turned on, and it dropped so much electricity, just like that surge of people trying to take electricity off of the grid, that they had to get help from France to help make it so that you didn't have a blackout. Like, the grid went out. So there's also the engineers, the planners, the scientists, and they also know how this kind of unpredictable system works. And they know this before we ever spend any money in construction. And that's because we've got all of these fancy design tools and controls. We can help alleviate some of the burdens and unpredictability through the calculations. And we've got what we call digital twin modeling. So you've got the physical twin, which is the actual system out there. And then you have your digital twin, which is the modeling tools and things that that the engineers work with. And they've got the pump curves built in, they've got automation built in, they've got basically all the tools you need to reiterate scenarios that might actually happen in the system. So you can see how the more complex the system, the more complex the tools, and the more complex the workforce and the different people that have a say in how it works and what goes on in the system. So it's this idea of interlocking people and interlocking strengths of those people. If engineers design in a bubble, we might say, hey, you need a bigger water treatment plant. You got a lot of water coming in. Or we might say, hey, it's not really the engineering side that needs to change. Maybe we just need to get out there and educate the community to, hey, this is what happens, and this is really how much it's going to cost you whenever you don't, when people don't reset that default time setting. If you were to just change it by 15 minutes, 30 minutes, maybe every other day instead of every day watering your lawn, it would really change what we need to design in order to meet those requirements. You could talk to the politicians. The politicians could put on a restriction to conserve the outdoor water use. Again, just that idea of like encouraging people to take a look at what is actually happening and how it is affecting their pocketbooks. So the biggest, highest use consumers are what we call industrial users. So these are like manufacturers. They also use the water from the system. And I'm thinking in terms of, wastewater treatment plants. You have lots of different streams coming in. They're coming in from domestic toilets. They're coming in, from runoff on the road, and they're coming in from these industrial users. And so the streams that come from the industrial users they might have metals in them. They might have different things that you wouldn't find in industrial or in domestic wastewater. You could treat it all at the, if we can only see what's happening at the plant, we just treat it all at the wastewater plant. Or if we know that, hey, there's metals in the water, it's obviously coming from this specific manufacturer, maybe we go to them, we build a relationship with them, and we offer them a rebate so that they can treat the metals on site there. Or maybe we just pay for it because it's cheaper for us to pay for it, that system, to treat the metals on site, than to pay for it over here in our plant, which is treating so much more water that doesn't have metals in it. And it, all gets mixed up together. As these different streams are coming into the plant, they're all routed together in different places. So what makes more sense for the system? There's lots of different options. It's this idea of like optimizing and how do we get the best system. And there is no right or wrong answer. It's different for everyone. Everyone, if you've got 10 engineers, you'll have different answers. And so it's how do we get the right perspectives in there in order to solve the problems for the city. So the owners are the next part of this system. The owners take the ideas and they have political agency. So they begin to capital plan for the upgrades and the projects. They allocate the contingencies for emergency planning. They decide when to analyze some more or just, accept that there's going to be some risk that to over-design it is probably not worth taking the risk of just going forward with the project. And they can work with the governments, or they are the governments, and they put taxes on the ballots, and they get grants funded for the cities and different municipalities and projects around the city. There are also private companies that work with consumers. There's lots of private company water providers, and all these different types of owners. They take their ideas and they're able to get the essential funding, the support, and the actions that's needed to make it a reality. So once you have the ideas and the funding model, the next step is then buffing out the idea. We'll have some projects that are, say, feasibility projects. Would this system even work? Is this even a good idea to try to store, I do sometimes aquifer storage and recovery, which is storing groundwater or storing drinking water in the ground and then pulling up when you need it to offset, like during droughts, so that you can supplement your water supply during a drought. But obviously it only works in certain geological conditions, and so you have to do a study to see if it's even going to be applicable or workable for your condition. So then we get to the consultants. The city generally, or any owner generally, has their own staff engineers. The staff engineers do whatever are the projects that you have most often in the city, or they create the standard details that will then be required by anybody who works for the city. But if you have very specialized work, you tend to need people that are, very specialized. And so if you've only got one biosolids plant in all of the city, you're not going to have one biosolids expert that even lives in the city. So you're going to have to consult with a consultant, and these consultants kind of know what the biosolids plants in every city look like, and they're able to take lessons learned and ideas from other plants to apply to your city. Or the other type of consulting model is, say you've got one project that is what we call a fast burn, and it's happening in a very short schedule. Then you bring on these consultants because you need to be able to offset the work so that it can actually get done in that time period. Depending on the type of project, you'll have different types of consultants. You could have project managers or program managers. You could have people that are actually doing the design. You can have a company that solely coordinates with landowners. I was on a project once where we had a local company that went and negotiated with the landowners so that we could go and do an investigation on their land. You've got environmental consultants, you've got, the civil engineers, lots of different types. I was once on a project where we were the engineering consultant program manager, and we had a sub-consultant that was contracted to us to help us meet our diversity and inclusivity goals, which they call economic inclusion. And ultimately, you guys paid for it as the consumer because it, is built into your taxes and how you purchase things that come out of the system. We needed it because the system was so complex. We needed a specialized person that could dissect, could find us work and help us understand the procurement rules. She was connected to different people in the city that had different talents that we could potentially also sub-consult with so that we could help to meet the rules. So logistically, you can see how sometimes the inclusivity and diversity rules for the city are a little bit of a nightmare, and they cost you guys money. So there's a lot of policies, a lot of procedures, and I don't think that they're necessarily working for us in the way that we intended for them to be working. Each city, each state, each transportation department has their own way of doing procurement. And they're all trying to be fair, and they're also trying to support the underserved populations and make sure that there's work there for everybody, but ultimately it's kind of a mess.